we're still going to take this polynomial function. We're going to determine how many complex zeros just by looking at it and saying by the fundamental theorem of algebra, we know how many complex zeros there are. We're going to do Descartes' rule of signs to find the possible positive and negative real zeros. We're going to do the P over Q to find all the different rational zero possibilities we have. Then you'll either take a calculator or you'll take a decimals or something. I'll sanitize. Okay. And then we're going to sketch the graph. Once we've sketched it and we've figured out what the multiplicity is for all these nice rational zeros that we've looked at, then we will do some synthetic division, maybe some factoring, but since these are irrational and imaginary numbers, it's going to be quadratic formula or solving. And then we will rewrite our entire polynomial as a product of linear factors. Okay, so let's get as much as we can on this one screen here. So number 1A. We got 8x to the 5th minus 12x to the 4th plus 6x cubed minus 5x squared plus 3. Okay? So by the fundamental theorem of algebra, Jart wants to tell me 5 complex zeros. Sure. Awesome. 5 complex zeros is what we got. Okay. B. We're looking at how many positive real zeros do we have? Okay. All right, Elijah, Descartes' rule of signs. That's a positive, that's negative, that's positive, negative, positive. Okay. How many sign changes do we have? 4. So that tells me there could be 4 positive real zeros, or 2, or 0. There might not be any positive real zeros. It might be 2, it might be 4. Okay? So if I'm looking at my calculator and I see 1 positive real zero, I can move it to the right further because I know there's at least a second one. Okay? It's either 0, 2, or 4. Now, for negative real zeros, we need to find out the signs of f of negative x. So we're going to take the exponents that are odd, which is 5 and 3, change those signs. So this plus becomes a minus, this plus becomes a minus. So minus, 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 plus. So Emma, how many negative real zeros do we have? Just 1. Okay? It's not 1 or 0 because we can't subtract 2 from 1 and get 0. Right? You might get a pair of imaginaries to bring it from 4 to 2 and another pair to get it to 0. But 1 is how many negative reals. So to the left of the origin, it's going to have 1 x-intercept. You're going to have the x-intercept. It's going to have. For C, C is saying how many of these or what are the possible rational zeros? What are the rational zeros we're going to be looking at? So how do we find that? We look at P over Q. P is the constant. Q is the leading coefficient. And we take all the factors for P and all the factors for Q. Okay? So the factors for these two numbers. So the factors for 3 are just plus or minus 1, plus or minus 3. Factors for 8 are 1, 2, what else? 4, 8. Okay, cool. So now I'm going to do a little mix and match. Let's take plus or minus 1, match it with each of these 4 denominators. I want to go lowest number to greatest number, so I'm going to go plus or minus 1/8, plus or minus 1/4, plus or minus 1/2, plus or minus 1/1, which is plus or minus 1.
Do you have to write plus or minus for like every single one, or can like we put the plus or minus in and like put it?
You're just trying to be lazy on writing plus or minus?
I mean,
Yeah. If you put plus or minus for them all, it's fine. Okay. So now let's take the plus or minus 3. So let's go plus or minus 3/8, plus or minus 3/4, plus or minus 3/2, plus or minus 3/1. So these are the only possible rational zeros. Okay? That means these are the only zeros that you could find by factoring. Okay? You can only find these by factoring. So like if it was a 3/8, you know, if it was, what would it be? It would be like 8x plus 3. If that was a factor, you'd subtract 3 and divide by 8. Okay, so this factor would give you a 0 of negative 3/8. Okay? For 3/4, you would have, what, 4x like minus 3. Okay, if this were a factor, you'd add 3 divided by 4. Oh, that's 3/4. Okay? So all of these rational numbers are candidates for being rational zeros of your original polynomial. Okay. So if it's not one of these, okay, if it's not one of these, when you look at your graph and you see the real zeros, then it's not going to be rational. Okay? It's going to be an irrational real number. So D, you graph it. So if you've already graphed it, great. I sketched what the graph looks like. If you want to look at it, go for it. It crosses the x-axis at negative 1/2, and then it bounces off the x-axis at positive 1. Okay? So it starts down at negative infinity, which you should know because positive leading coefficient, odd degree polynomial, it's a down up. So it crosses through at negative 1/2, and it comes over and it bounces off of the 1, and then it goes up. So it's a down up. So the real zeros that you've got here, you see there's 2 of them. That's what happens to have a multiplicity of 2. Now, are these in this list? If they are, then they're rational. Negative 1/2. Yep, it's right there. Positive 1. Yep, it's right there. Okay. So, negative 1/2 is a 0 with a multiplicity of 1. 1 is a 0. What's a multiplicity?
2.
It's 2 because it bounced. Yeah, it bounced. Okay. So how many of the 5 complex zeros
2.
have we found?
3.
Yeah. This one has multiplicity of 2. This one says
-1.
we found 3 of the 5, yeah, that are complex. And then if you go back here, you say, did we find that negative real zero? Yeah, we did. Right there. What about the positive real zeros? Well, we have one with a multiplicity of 2. So it looks like it's going to be 2 positive reals, 1 negative real, and that means we got 2 more that are going to be imaginary. Okay, so we got to find the imaginary ones. How do we do that? We are going to synthetically divide this little baby. So we're going to do it twice with the 1 and once with the negative 1/2. So let's set it up. Let's do the ones first, because I really like to multiply by 1. Okay, so we've got 8, and negative 12, and positive 6, and negative 5, and 0, and positive 3. Okay? Now, if you had forgotten the 0, you would be able to catch yourself. Because if you do this and the remainder is not 0, then the factor theorem tells me it's not a factor. X minus 1 is not a factor. But I know X minus 1 is a factor. We just saw it on the graph. Okay? So then you go back and say, what did I miss? Oh, the placeholder, X to the first. I need my 0. Okay, so let's see. Matt, you want to walk me through?
Yeah, it's 8.
8.
8.
8. Yeah.
4.
Yeah. 2. 2.
3.
Yeah.
3.
Yeah.
3.
Yeah.
3.
Yeah.
0.
There, sound like an auctioneer. I like it. Good. Remainder is 0, which you knew it was going to be. Okay? It's nice. All right, I'm going to give me a little bit of space to go up here and write a little bit. So I've got the 8, negative 4, 2, negative 3, negative 3. So let's do the second one now, because there was a multiplicity of 2. Okay? You want it there, sir? Go for it. 8.
And then bring it up there.
8.
4.
Yep.
And
Okay.
bring it over. And 6. Wait.
Oh, you mean this? Okay, I got
Yeah.
you. Yeah, I got you.
You bring that part up, and then it's 3.
Yeah.
Then you bring that part up, and it's 0.
That's my remainder. Okay. So we have gone from x to the 5th down to x to the 4th. Now we're at x to the 3rd. Let's get it down to x squared. My last 0 that we know is a negative 1/2, which has a multiplicity of 1. Okay. What's this one? What's this one? You're the only one that wants it? Okay, I'll let you have the joy for now.
So you bring that 8 down.
Yeah,
Multiply, so then it's negative 4.
yeah,
Then 0.
yeah.
That 0 up, 6.
6.
And then multiply that, it's negative 3.
Yep, and there's my last remainder. So this is 8x squared plus 0x plus 6. So we want to find our last two zeros. Okay, our last two zeros we can find by taking 8x squared plus 6 and setting it equal to 0. Okay, 8x squared plus 6 equals 0. So now let's do some arithmetic. A little bit of algebraic solving. Minus 6. So I get 8x squared equals negative 6. Next step, divide by 8. So I've got x squared equals negative 6 over 8. I'm going to reduce that to 3/4. Okay. You're going to square root both sides, which means you're going to plus minus your answer. All right. In the denominator, we've got the square root of 4. Well, that's nice. That's 2. In the numerator, we got square root of negative 3. Well, remember, negative 3 is negative 1 times 3. Square root of negative 1 is I. So it'd be I root 3. Or root 3I, whichever way you want to write it. As long as you don't put the I underneath the little radical, don't put it in the square root, you're in good shape. Okay? So, these are my last two zeros. And I knew they were going to be imaginary because they were not in the x-intercepts that we found before. So finally, you are supposed to write this standard form polynomial as a group of linear factors multiplied together. Okay. You want to tell me what to write?
Is this an F?
Yeah, this is F.
X minus 1,
X minus 1,
and then x plus a half.
X plus a half. People talking, what we got? There's more, what are we
We
doing?
have to square the x minus 1.
Square the x minus 1 because it had a multiplicity of 2. Good. Now,
Do like x minus, then in parentheses, plus the x plus, then
so x, yeah, it's always x minus.
x minus.
So it's x minus the, you can take the positive I root 3 over 2. And then you can do x minus negative, which would be x plus I root 3 over 2. Okay. And that's good stuff. I only have one problem with it. Say that again?
It's not polynomial.
Why not?
Just isn't.
Tell me about the coefficients in a polynomial. Well, in general, we want to have whole numbers, they're coefficients. But even more so, what is the leading coefficient? It's an 8. It's an 8. So if I take the 1 and square it times the 1 times the 1 times the 1, my leading coefficient of this is 1. My leading coefficient of this is 8. So they're not the same. They're not the same. This is why I'm glad we did slip, divide, and slide. Because, as we mentioned before, if I wanted like 3/4 to be my 0, that's the factor. We wouldn't do this. Okay? You would actually do the slide in slip, divide, and slide. Okay? So if there's a denominator, we can't have that in a fully factored form of a polynomial. So we're going to slip, divide, and slide. Now we're just going to slide. So x minus 1 is fine. But for this to be a half, I'm going to slide that 2 in front. It's going to be 2x plus 1. I'm going to slide this 2 in front. It's going to be 2x minus I root 3. And it's going to be 2x plus I root 3.
It's pretty simple.
That's it, yeah. Now, I did upload some filled out notes. And the only thing I don't like about the filled out notes is it didn't include this last step. Because there's nothing wrong with this. If I type this in, it's going to have the same exact zeros with the same multiplicities. The only problem is it's not the same polynomial. Okay? It's not the same polynomial. So this is your fully factored version of your original polynomial. All right? Any questions on this guy? That's it. That is as in-depth and deep as you're going to get, really. So if you can do that one, you're in really, really good shape. Let's look at question 2. G of x equals x to the 5th minus 7x to the 4th plus 16x cubed minus 16x squared plus 7x minus 1. Okay? All right. Let's go with, let's see, Sawyer. How many complex zeros do we have? 5 again, because it's a 5th degree polynomial. 5 complex zeros. Awesome. Awesome, awesome. Okay. For B, positive real zeros. Okay. Lucy, how do we figure out how many positive real zeros we have?
Sign changes.
Okay, plus, minus, plus, minus, plus, minus. How many we got? 5. Okay, so positive reals, 5 or
3.
3 or 1. Good, awesome. Okay, Chantal, how about negative? There's a 5 and a 3 and a 1. Okay, so we're going to switch this plus to minus, this plus to minus, this plus to minus. Isn't that nice? So how many negative real zeros, Chantal? 0. There aren't any. So if you're graphing, you don't even need to look on the left side of the origin because there aren't any x-intercepts because there's no negative real numbers, rational or irrational, that'll give you a 0. Right? That's good information. You don't have to go fishing around on the left side of the origin. Okay, rational numbers. Rational zeros. Factors of P over factors of Q. You don't get much better than this. P is -1, so plus or minus 1. Q is 1, so plus or minus 1. So the only options according to the rational zeros test be plus or minus 1. But how do I know it's not -1?
There's no rational measures. There are no real.
Yeah, -1 is a real negative number. So I know that if there's going to be a rational number that's a 0, it's going to be 1. Okay? And all we've done is we haven't picked up a calculator. All we did is we looked at the signs and we did P over Q. Right? So if it's not 1, then you're not going to have any positive reals. Well, guess what? There's at least 1, so it's going to be a 1. Okay, so now we graph it in D. And your graph looks, I'll put my graph over here, a little more space. All right, it actually does come up. There we go. Let me get a different color here. So it does pass through before 1. And then when it gets to 1, it flattens as it crosses. Yes, that's correct.
But if there's 2 intercepts, then it must be 3.
Well, there's
Will be
another one.
Oh.
Holy guacamole.
3, 1, 1.
Yeah, so I know that 1 is the only possible rational 0 that we got here. But from the graph, I know that 1 has a multiplicity of 3. Okay, so that's going to be an x minus 1 cubed. And I also know from this graph that there are 2 other real positive zeros. Okay, so we got 3 of them here, 4, 5. So all 5 are going to be positive real zeros. But I also know they're not rational. I know the 1 is, but these 2 aren't. So I have 2 other irrational zeros. Okay, with multiplicity of 1 of each. How do I know that's not an imaginary 0? Good question. Right here.
Positive.
What's that?
Positive.
It's positive.
You see it?
Yeah, you can see it. That's an x-intercept. I see it. It actually physically touches the x-axis Therefore, it's a real number. Yes, John.
How do you get the multiplicity of 3?
Elijah, how do we get multiplicity of 3?
It flattens out when it crosses 1.
Yeah.
And does.
It
Oh, it
crosses
crosses like that.
and it flattens as
Okay.
it crosses.
I didn't see that flat.
Yeah, it doesn't just cross. It actually slows down and then it speeds up.
Okay.
Okay? So multiplicity of 3, multiplicity of 1, multiplicity of 1. But I don't know these other two numbers. So we're going to do synthetic division to find those two numbers. Okay? So for part E,
1, 3 times.
I know, we're just going to do 1 3 times. And I love multiplying by 1. All right, so multiply by 1. And we've got 1x to the 5th minus 7x to the 4th plus 16x cubed minus 16x squared plus 7x minus 1. This one didn't even have any zeros. It's a placeholder. Okay? All right, let's see. Who else? Let's just do this. 1, 1, -6, and 6, 6, 1, 1. Remainder 0. So far, so good. Okay. Factor theorem says the remainder's got to be 0 to be a 0 and to give me a factor. Okay, there's multiplicity of 1. Now it's down to x to the 4th. Okay, let's do the second one. Bring it down. Okay. Second one brings us down to x cubed. Now we'll take the third one. And we multiply, and we add, and we multiply, and we add, and we multiply, and we add. Okay, so here we got 1x squared minus 4x plus 1. So we'll set that equal to 0, and we'll find our last two irrational zeros. Okay, we'll find out what these irrational zeros are. Okay. So, x squared minus 4x plus 1, set it equal to 0. Obviously, it's not factorable because we know these are irrational. Okay? If it's rational, we factor. If it's not rational, it's going to be quadratic. So, a is 1, b is -4, c is 1. So we've got the opposite of b, so positive 4, plus or minus the square root of b squared minus 4 times a times c, all over 2a. Now, notice that the question says that they want exact values for your irrationals. So we're not just going to put this in the calculator and give me some weird decimal. We're going to come up with the exact value. We're going to keep the square root in. Okay, so 4 plus or minus, what's -4 squared? Positive 16 minus 4 times 1 times 1. So that's root 12. Now, geometry, unit 7, day 1. We took root 12 and we said, I want you to simplify root 12. Yeah, so you took the biggest square, perfect square that's a factor of 12, and we separate it. So root 12 is root 4 times root 3. And root 4 is 2. So this is 2 root 3. So I'm going to rewrite this as 4 plus or minus 2 root 3 all over 2. Now we can reduce, doing the little heart reduction, which will also allow me to split it into 2 fractions. So I got 4 over 2, which is 2, plus or minus 2 over 2 root 3, which is just 1 root 3. All right, root 3. So these are my last two zeros. Now, we had said there are no negative real zeros. Well, these are both real numbers. 2 plus the square root of 3, it's positive. 2 minus the square root of 3, that's positive. So these are those last two of the 5. They are positive, they are real, and they are our zeros. So now we will finish up with F. Well, this is a g of x. We'll call it g of x equals. What are we going to write? This comes straight off of the last quiz.
X minus 1.
X minus 1 cubed, because it's multiplicity of 3. Okay, so this is the one that, for those that took it yesterday, a handful of you had trouble with this. Okay, it's x minus one of them times x minus the other one. Okay, so we've got 2 plus root 3 and 2 minus root 3. There you go. That is an acceptable answer right there. 2 plus root 3 and 2 minus root 3 are conjugates. What I had some people doing was they didn't change the plus to minus. They changed x minus to x plus. Okay? The conjugate is of the 0. The 0 is inside these parentheses. Don't change x minus to x plus. Okay? It's x minus this conjugate times x minus the other conjugate. Okay? That is it for question 2. Those are the 2 big questions. Questions or discussion on this? It's a lot like what we've been doing. It's just that now we're getting into the square roots for our answers. It's not quite as clean as when it was just numbers without the roots. Now we got I, we got regular radicals. Okay, so now question 3. Determine all the remaining zeros of p of x, which is a 4th degree polynomial. And they give you one of the zeros. But here's the new curveball. We're going to give you a zero that happens to be irrational. This is the first time we've done that. That's kind of cool. Okay. Hopefully you can see it. If not, you got it in front of you. Okay. So 1 plus root 5 is a 0. That's nice. So what have we been doing with the zeros? When I give you I say 5 is a 0 of this, what did we do with it? Exactly. We did synthetic division. So guess what we're going to do? We're going to do synthetic division. So 1 plus root 5 is a 0. We put 1 plus root 5 right out there. We're going to do the same thing we've been doing. So 1x to the 4th minus 2x cubed plus 5x squared minus 18x minus 36. Cha-ching. Okay. Bring your 1 down. 1 plus root 5 times 1 is nice. Okay. Adding. When you add terms, you can only add like terms. So what is negative 2 plus 1 plus root 5?
Negative 1 plus.
Yeah, all I can do is take the negative 2 and the 1 and add them. So that's going to be negative 1 plus root 5. Right? Don't get hung up on that. Now we multiply. Yeah. This is when I usually start hearing the moans, but don't worry. Okay, it's not going to be a bad thing. These all have like little nice things come out of them. You watch. So 1 plus root 5 times negative 1 plus root 5. I'm going to give myself a little workspace over here. 1 plus root 5 times negative 1 plus root 5. Okay, it's two binomials. Let's FOIL it. Multiply 1 times negative 1, negative 1. 1 times positive root 5, positive root 5. Root 5 times negative 1, oh, I told you it's going to be nice. Minus root 5. Root 5 times root 5 is root 25, which is 5. So looky, the fun stuff that we have. Plus root 5 minus root 5 cancel each other beautifully. We get negative 1 plus 5. So all of this, it's 4. Yeah, I love it. Okay, so there's a 4. Add 5 and 4 to 9. 9 times 1 plus root 5. Hopefully you don't need to do this for the workspace, but if you do,
I can tell you what's equal.
mean 0 at the end? Yeah. You know this is going to be a 0 because they said it's a 0. So you know this is going to be 36, which is pretty sweet. Okay? So 1 plus root 5 times 9 is 9 plus 9 root 5. Add that to negative 19. We get negative 9 plus 9 root 5. Okay, so now one more time we got to multiply it. Now you might just say, I know that it's going to have to be 36, but what if you did it incorrectly? If you did it incorrectly, you need to check yourself because then you won't get the 0. So let's do it. 1 plus root 5 times negative 9 plus 9 root 5. Let's multiply those. 1 times negative 9, 1 times 9 root 5. Oh, here it comes again. Minus 9 root 5, so they cancel. And then positive root 5 times positive 9 root 5. Root 5 times root 5 times 9. That's 5 times 9, which is 45. Okay. Negative 9, these cancel, plus 45 gives me 36, which is what we were hoping for. That's great. So we've got our 0 remainder, don't even have to worry about it. So we went from x to the 4th down to x cubed. But we don't want this for a coefficient. We definitely don't want this for a constant. Wouldn't it be great if we had another 0?
We do.
We do. What do you speak of, this strange notion of another 0? What is this other 0 of which you speak? Yeah, this is a radical 0. Radical zeros come in pairs. So the conjugate is 1 minus root 5. So they said, determine all the remaining zeros. Well, this is one of them. I determined it just by looking at this 0. So, negative 1 minus root 5. And as much fun as the other one was, this will be more fun.
Why is it negative 1?
Oh, I'm sorry. 1 minus root 5. This one will be more fun. I guarantee it. Check it out. Bring the 1 down. Multiply. What do I get? 0. Yeah. Negative 1 and 1, cancel. Positive root 5 minus root 5, cancel. So this times 0. 1 minus root 5 times 9 is 9 minus 9 root 5. And look what that happens. Bingo, another 0. So this gives me x squared plus 0x plus 9. All right, so how many complex zeros are there? 4. We got 2 of them. Let's get the other 2. So we got x squared plus 9 equals 0. Now, could you do this with quadratic formula? If you wanted to. A is 1, B is 0, C is 9. But that's more work than you really need to do. Let's just do some algebra 1 stuff or algebra 2 stuff. Subtract 9. Now what?
Square root it.
Square root it. If I square root both sides, I must plus minus my answer. Yeah, this is square root of negative 1 times square root of 9. That's I times 3. So 3i. So my other two zeros are 3i and its conjugate, negative 3i. So we got two irrationals because the irrationals come in pairs. And we got two imaginaries because the imaginaries come in pairs. Okay? Questions, observations? How many are dreading the fact that they are going to be anxious about foiling? Nobody? That's good. That's good. That's great. Okay? Because other than the foiling, there really isn't anything extra on this. Okay? You got square roots. No big deal. Okay? So let's look at this last guy. This time, instead of a square root, we put an I in the zeros. So this time I'm giving you the imaginary, and you're going to have to work from it, as opposed to I give you a real one, and then you have to find the imaginary. So it's kind of like, just the converse of what we've been doing. So here we go, negative 1 minus I. By the way, what's the first zero that we're going to know, other than this one? Negative 1 plus I. So that's the second out of the 4 complex zeros. I know there's going to be 4. This is number 2. Right? Got this guy, got this guy. So let's do some synthetic. So negative 1 minus I is the first one. 1x to the 4th plus 2x cubed. What's next? 0, then negative 4, and negative 4. There you go. Don't forget your placeholders. Now, if I did forget the placeholder, I would get a remainder that's not 0. And since they told me it's a 0, I would know I got to go back and work on it. Okay, so look for those little red flags that will help you and guide you to get the right answer. Now, here we go. Bring the 1 down, multiply. Add 2. What do you get?
1 positive.
Positive 1 minus I. Because 2 plus negative 1 is positive 1. Okay? Multiply. Oh, we're going to foil it. So get a little workspace over here. So 1 minus I times negative 1 minus I. Okay? You're going to find, just like the other one, nice stuff's going to happen. Okay? Watch. It'll be cool. 1 times negative 1. 1 times minus I. Minus 1 times minus I is plus I. Canceling nicely. Now, this is the only other part that I would say if you're going to have difficulty, people will have difficulty here. Treat it like it's an x. What's minus x times minus x? It's plus x squared. So this is plus I squared. Okay? Yeah. Yeah. So the minus I and the plus I cancel beautifully. So that's negative 1 plus I squared, which is negative 1. So it's just negative 2. So this times this gives you negative 2. Perfect. Add them. Negative 2 times negative 1 is 2. Negative 2 times minus I is plus 2i. Add them. Exactly. Now, what do I hope is going to be right here?
0. I mean, no. 4.
I hope it's going to be a 4, and that's going to be a 0. But let's check it. Negative 1 minus I times negative 2 plus 2I. What?
Did you get 2i?
This guy?
Yeah.
Oh, I multiplied negative 1 minus I times negative 2. So negative 2 times negative 1 was 2. Negative 2 times minus I was plus 2I. Good question. Good question. Yeah, distributive property. So let's FOIL this. Negative 1 times negative 2 is 2. Negative 1 times 2I is minus 2I. Negative I times negative 2 is plus 2I. There they go again. Gotta cancel. Minus I times plus 2I. What's minus I times plus 2I?
2I squared.
Minus 2I squared. Okay? So this is 2. Those cancel. Minus 2 times negative 1, because I squared is negative 1. Well, that's 2 plus 2. That's 4. There's my remainder of 0, just like I hoped. Okay, so we've taken care of the dividing by the first 0. Now let's divide by the second 0. So negative 1 plus I. All right, bring down your 1. I'm telling you, the second one is always going to be magical. So we got negative 1 plus I. What happens?
0.
Yeah, they cancel. 1 and negative 1 is 0. Negative I and positive I add up to 0. So this times 0 is 0. Negative 2. Okay, negative 2 times negative 1 is 2. Negative 2 times I is minus 2I. And yes, we get a remainder of 0. Pretty sweet. So this is 1x squared plus 0x minus 2. Let's find our last two zeros. Let's add 2, take the square root. Square root with a plus minus. So we got positive root 2 and negative root 2. Plus or minus root 2. So I've got all 4 of my zeros that we have looked at here. We said that there were 4 complex zeros. We found all 4 of them. 2 of them had imaginary parts. 2 of them are irrational and have radicals in them. Well, we found them all. That's where we have broken apart from day 5. Day 6, we're starting to do synthetic division by imaginaries and irrationals. Which is kind of nice. So any questions, concerns, revelations on this one? Chantal.
Are we ever gonna have like say we're 0x? Are we ever gonna have one that has like a term there? I know we've talked about that.
Well, we could either factor it, or if it's not factorable, what could we do?
Quadratic.
Quadratic formula, yeah. The only reason I'm not using the quadratic is because that's a 0. And I can, yeah, it's just
Are we ever
easier.
gonna have problems like that, so that we have to use the quadratic?
I would anticipate it. Yeah, I would definitely anticipate that. Okay. Good question. Any others?